Good morning, students. So in our last class, we complete up to question number 8 from the exercise 6.2, isn't it? So here another 2 questions are remain. So today here we discuss the question number 9. And if you see here, the question is already given here, and the question is given like in this way: ABCD is a trapezium. So all of you know the property of trapezium, opposite sides are always parallel. So trapezium in which AB parallel to DC and its diagonal intersect each other at the point O. These two conditions are given, and now here we need to prove AO by BO equal to CO by DO. So first of all, to prove this result here, first of all we have to draw a trapezium here where AB parallel to DC we have to write. So in this case, first of all, if you consider a trapezium, suppose the trapezium is here, we consider this one is a trapezium here, and in this trapezium, if we denote this one is by A, here it is B, this one is C, and this one is D. According to our question, this AB parallel to DC already given, first of all. So now here A, B, C, D, this one is a trapezium here we consider, and in this trapezium its diagonal intersect each other at point O. So that means what you have to do here, we have to draw the diagonal. So if you draw the first diagonal here, this one is here we get AC, and another diagonal we draw from B, and which one we get here, and these two diagonal intersect at one point, and this intersecting point is defined by here O. Is it clear? So this one is the diagram given here, and we need to prove the AO by BO equal to CO by DO. So actually this type of ratios are when we get with in basic proportionality theorem, actually we get this type of ratios, is not it? So now for that reason, according to our Thales theorem is what? If two lines are parallel, then other two sides are divided in the same ratio. This one is known as Thales theorem. So that's why here, first of all, what you have to do, a little bit construction we have to do here, and the construction is what? So here we have to draw a line through O. First of all, you see, we have to draw a line through O in such a way that the line must be parallel to AB, or if the line is parallel to AB, so automatically this one is parallel to DC also, because AB parallel to DC given to us. So first of all, a little bit construction here we have to do. What you have to do, we have to draw a line passing through this O in such a way that the line must be parallel to AB. So that's why here, if we draw the line, this one you see here, if we draw a line in this way, the line intersecting the side AD and BC at two places, which one is we denoted by E, and as well as if we denote this one is by F, and the line we draw in such a way that the line must be parallel to AB as well as DC. Is it clear? So the first of all, this construction we have to do here to solve this question. So what you have to write, draw a line EF passing through. So here you have to write, draw a line passing through O. The line is which one? EF passing through O in such a way that the AB parallel to DC. This one at first we have to write. Is it clear? So that's why here, when we have to start the solution, we have to write here. In this way you have to write, draw EF. Draw EF, and this one is passing through O. Draw EF passing through O such that you have to write such that AB parallel to EF. Only one part here written, AB parallel to EF. That means it is automatically parallel to CD or DC also. So first of all, here we have to write this one, draw EF passing through O parallel to O such that parallel to AB. Is it clear? Now after that, now here the main part come here. If you see, when we draw a parallel line EF, that means if EF is parallel to AB or if EF is parallel to DC, that means here you can write in this also parallel to DC, because these two are already parallel, and here EF is parallel to both sides. So now in this case, if EF is parallel to DC, that means this EU is also parallel to DC. isn't it? So first of all, what you have to write, if you see the diagram in triangle, first we consider this triangle ADC. If we consider the triangle this one ADC, separately if we draw here the diagram, we get like in this way. You see, this one is A, here it is D, and this one is C, isn't it? And now here this line we get here E, and at this place it is O. Clear? So already we write EF is parallel to DC. So from here easily we can say EO is also parallel to DC, or we can write OE is parallel to DC, isn't it? So if these two are parallel, so easily we can apply here Thales theorem. So comma, here you have to write EO parallel to DC, because already EF is parallel to DC we write, so no need to write here, directly you write EO parallel to DC. Clear? So now next you write, now using Thales theorem, or you can write here by using Thales theorem. By using Thales theorem, what we get here, the third side is this one, the opposite vertices is A, so that's why here we can write AE by ED. So in this case we write here AE by ED is equal to, you see here, AO by OC. So here we can write here AO by, either you can write OC or we can write CO also, AO by CO. Is it clear? So this one at first we get AO by AE by ED is equal to AO by OC, or we can write CO. So now we put this one is equation number 1. Is it clear? Okay. Now after that, the first triangle, which one we consider? ADC. This triangle we consider. Now with related to side AD, here we get another triangle, one more triangle. This one is the most important part. Which triangle actually we have to consider? At first we consider the triangle ADC. So at the same time we have to consider the triangle in such a way that one common side required. So that means here you see ADC. In ADC, AD is here. So with related to this AD, we get another triangle here. And this triangle is which one? ABD. If we consider this triangle, then AD again we get. So second time what you have to write? Second time we have to write in triangle. The next one you write in triangle ABD. So that's why here we have to write triangle ABD. First one we write ADC, and now here we write ABD. So separately if you draw the diagram here, the diagram we get like in this way. You see here. So diagram we get in this way. And now here this one is A, and this one is B, and here it is D. And in this case again it is E, here it is O. You see here A, B, D, E, O. So second time this EO is parallel to AB. So that's why here we have to write this one is EO parallel to AB. So if these two sides are parallel, so easily we can apply here the Thales theorem, isn't it? So now here again we apply here the Thales theorem. So that's why here you have to write by using Thales theorem. So if you see here, by using Thales theorem, so what you have to write? Now one thing here very important, this one you see here, the third side is AB. So for this third side AB, the opposite vertices is here D. So that means when we start this one, we start from D. In this case, the third side is DC and the opposite vertices is A. So that's why we start from A. So in this case, the third side is AB, the opposite vertices is D. So that means we have to start from D. So in this case, what you have to write? DE by EA, or we can write AE, meaning is same. So that's why here in this case, we have to write DE by AE, or if you want, then you can write EA also. DE by AE or DE by EA, meaning is same. And in this case we write what? DO by BO. In this case we write here DO by BO. Is it clear? So we write this one. So in this case you see here DE by AE equal to DO by BO, and here we get AE by ED. AE by ED is there, and here AE by DE is there. So DE means also we can write ED. So if we interchange this one, so the right hand side also we have to interchange. So in this case, so next line from here, from this one we write, the next one is here. If we interchange this one, or by cross multiplying also the meaning is same. So here we write AE by DE. So this one we write here AE by DE. So AE by DE equal to, if we interchange this one also we have to interchange. So that's why here we have to write this one is BO by DO. Clear? So now here you see AE by ED is there. So AE by ED, DE means ED. Here also this one we get. So we put this one is equation number 2. Is it clear? So now here AE by ED, A by ED. If the left hand sides are equal here, so easily we can compare, then the right hand sides are also equal here. So that's why here we have to write from 1 and 2. So therefore from 1 and 2 what we can write, if the left hand sides are equal, then the right hand sides are also equal. So that's why here we have to write this one is AO by CO equals to, this one we write here BO by DO. Now let's check out the proof here. So in this proof you see here we need AO by BO equal to CO by DO, but here we get AO by CO equal to BO by DO after comparing 1 and 2. So if you cross multiply this CO and BO, then what we get here, if you see this one is, we get here AO by BO equals to this one we get here CO by DO. Now let's check out the proof. So you see here AO by BO, AO by BO and CO by DO. So that means our proof is here complete. Is it clear? I hope all of you understood this one, and this one is question number 9. So in our next class we continue this exercise, and one more question is left here. So in our next class we have to discuss the question number 10. Is it clear? Okay, thank you.